Okay, this is Mrs. Davis. This is lesson 113, 114, and this is video 6. I'm just doing example 7, 8, and 9. All right, for example 7, it says the volume of a right circular cone, which here's what a right circular cone looks like, right? It looks like that, like an ice cream cone. If the height is twice the radius, so let's write that down. H equals 2r. Express the volume as a function of the radius. So here's our formula, and you see how it has an H and an R? Well, they want to just have R. So we have to replace H with what it is in terms of R. Well, we just wrote it. H is 2R. So where H is, we'll write 2R. So the volume would be 1/3 pi r squared times H, which is 2R. So let's simplify that. So the volume equals 2/3 pi r cubed. 2/3 pi r cubed. So there's the volume expressed as a function of just the radius r. Now it says find the volume of a paper snow cone cup whose radius is 2 inches. Using that formula, we just go in V equals 2/3 pi, and radius is 2 cubed is 8. So we have V equals 16 pi over 3. And then that's okay. We're not going to look up in our calculator. This is fine. So let's see. Is it give us any units or something? Yes, 2 inches. So the volume is inches times inches times inches, right? So this would be inches cubed. All right, so there's the answer for example 7. Let's look at example 8. Grain is leaking through a hole in the storage bin at a constant rate of 6 cubic inches per minute. So that's the volume that the grain is leaking. Now that's a rate, okay? The grain forms a cone-shaped pile on the ground. So here is the storage bin, and it's going down there. As it grows, the height of the cone always remains equal to the radius. So we can write that H equals R. If the cone is 2 feet tall now, how tall will it be in 1 hour? Okay, so first of all, let's figure out the volume at 2 feet and the volume, what is the volume initially? So we're going to put volume at 2 feet, okay, and that's going to be V equals 1/3 pi, and then it's 2 feet tall, so 2 feet is 24 inches, so we got to watch out because this was in cubic inches. The rate was given in cubic inches. So 1/3 pi r squared h. So, okay, I'm going to pause. Okay, so we know this is r squared h, but we also know h is r. So we can rewrite this, volume equals 1/3 pi r cubed. So the volume is 1/3 pi, and r is 24, so 24 cubed. So if you put that, let's see, what is 24 times 24 times 24? This definitely you can use your calculator for, and you get 13,825, but then divide that by 3, and you get 4,608. So that is equal to 4,608 pi. Okay. Now, okay, so next, inches cubed, okay? Now next, we want to know how tall will it be in 1 hour, all right? And we are given that it's going in at a constant rate, all right, of 60 inches per minute. So an hour is 60 minutes. So we would do 6 times 60, which is 360 inches cubed. That's how much would be gone, okay? Or would be, yeah, it's coming in or leaking at. So for an hour, you would have 360 inches cubed because it's 6 cubic inches per minute, so 60 minutes. All right, so if we, at 2 feet, we had that volume, and then we added that much volume in it, we can put that together. So add 360 to that. So we get, let's just multiply out by pi too. Is it 360? It's not 360 pi, it's just 360. This is supposed to be inches cubed. Okay, so calculator 4608 times your pi button, and then plus 360, and I get 14,836.458 inches cubed. All right, so that was smaller because pi is 3.14. You had to multiply that by 3.14, so it got significantly larger. So that's the answer for how tall will it be in 1 hour. I mean, that's the height. That's the volume. Okay, so now that we have that, we have to solve for the height. And so let's see, height in 1 hour, okay. If V is 1/3 R cubed and R is H, we can say that V is 1/3 pi H cubed also. So H would be the cube root of 3V, I'm solving for H cubed, over pi. So now we have the volume, so that's V, so we can just solve this. So I'll write down what you should put in your calculator. The cube root of 3 times, and you can't even see that this was a 1. Here, let me erase that. This was supposed to be 14. Okay, so times 14,836.458 over pi. And then you would take the cube root of that. All right, so let me do this into my calculator. Okay, so 3, well, I'll just do it all in one step. So, math is where your cube root is. So math 4. And so I have a cube root of 3 times, and then let me put that volume in, 14,836.458, and then divided by, get your pi button in there, and it comes out to be 24H would be 24.197 out to 3 decimal places. If I did everything right, 24.197, and the height would be in inches. So not an easy problem, a little confusing, but walk through it again. Remember, try to do this on your own, away from it if you can. And the last problem we have is about Hooke's law. It says that the force required to stretch or compress a spring by a distance is directly proportional to that distance. A force of 275 newtons stretches a spring 0.2 meters. Okay, so they're giving us some information, and they want to know how far will a force of 620 newtons stretch the spring. So first we have to write the equation. And if you remember, proportion, if something is in proportion, so we have A is in proportion to B, then it's A equals KB. It's got some constant times b, and that's what the equation would be. If it's that's directly. If it's inversely proportional, it would be A is B over K. Hopefully you've seen that before. So when we're writing an equation, let's use, did they give us some variables? Not really. So let's use F for force would equal K times some distance D. All right. And so we need to find this K, but they gave us this so we could find the K. They gave us 2 meters and its force is 275. So we'll substitute 275 equals K times 0.2. And so K would be 275 divided by 0.2. And that looks like it comes out to be 1,375. So that's what K is. So my equation is F equals 1375D. All right, now, how far will a force of 620 newtons stretch the spring? So we're going to solve for D. So D is F over 1375. So D would be the force, 620 newtons over 1375. So if you use your calculator again, 620 divided by 1375 gives you 0.451 meters. So D equals 0.451 meters. All right, so that's how you do that A. Now, what force is required to stretch the spring 0.1 meter? So now this is just use that same equation we did after we calculated K. K was the deal, okay? F equals 1375D. So F, the force we want, is 1375 times 0.1, which just means move your decimal point. So you have 137.5 newtons. There you go. All right, so that was lesson 1.3 and 1.4, okay?